Okay, so here we are, lesson 26, our summary. It says, in this lesson, we solve word problems that involve maximizing or minimizing a quadratic equation. We're also going to have a new and improved graphing parabolas procedure, so we'll get there. Let's take a look at number 1. It says, have a look at graph A, whose equation is given by y equals x squared plus 5x minus 6, and I've drawn the parabola here for you. Using the graph, write the coordinates of the x-intercepts. So go ahead and put a dot on the two x-intercepts, and then estimate their coordinates and write them down in that blank space. And note the S coordinates, each point has two numbers associated with it. So go ahead and write them with parentheses. What's the left-hand point? -6, 0 is good. And then it looks like the other one is 1, 0. Okay. And so our old technique, once we found those two numbers, if we wanted to find the vertex, we would say, hey, the vertex is smack dab in the middle of those two x-intercepts. What's the math word that says find the number smack dab in the middle? Average. So we're just going to average these two guys. So it says find the x-coordinate in the vertex by, fill in this word here, averaging the answers we got in part A. So we're going to keep using that same notation we saw a couple classes ago. X stands for x-coordinate. V stands for of the vertex. We just average -6 plus 1 divided by 2, right? Add the two numbers, divide by 2. So in this case, we get -5/2 or -2.5. Does that look right? For the x-coordinate of the vertex? -2.5. Okay, that seems reasonable. All right, so remember that finding the x-intercepts is easy here because we have the picture given to us. But if you don't have the picture given to you, then what you are really doing is saying, hey, if I want an x-intercept, I let y equal 0, and I solve that equation. And if we're lucky, the thing factors. If we're unlucky, we use the quadratic formula. Whether you're doing a box or the quadratic formula, both of those are fairly substantial processes, right? It's involved to find the x-intercepts. So I'm going to give you an easier way to find that vertex that does not rely at all on the x-intercepts. It is a simple formula. It is going to be your new best friend. It is right there. X-coordinate of the vertex is -b divided by 2a. The same a and b that we've been playing with in the quadratic formula. In fact, you don't need to write this, but a full-fledged quadratic formula actually contains this new formula inside of it. Do you see it? Do you see the -b/2a? Yeah, just ignore everything after that plus minus. There it is, -b/2a. It's just ignoring all of this stuff. Okay, so let's use our brand new formula to find the x-coordinate of the vertex. Here we go. Get this down right here for me. So we do -b/2a, negative. How much is b for this parabola? 5, right? A, B, C, same as before. 5 over 2 times a. How much is a? 1, right? 1x squared. So we get -5/2. Is that right? Is that what we got when we averaged the two x-intercepts? You bet. This should be a surprise to you that, like, we don't have to find the x-intercepts and then average them. We don't need to find the x-intercepts at all. There is just a direct, simple formula to find where the vertex is located. Okay, so keep in mind, this is still only the x-coordinate. We don't yet know the y-coordinate at that point. To find the y-coordinate, there's no shortcut here. You just have to plug in -2.5 in for the x's, right? And do a calculation to find y. Okay, so let's see here. So here's the calculation. We'll just read it, and it says, you plug in the -2.5 for all the x's, and eventually you get -12.25. So let's write both coordinates here of the vertex. How much was x? Which was the x-coordinate of the vertex? It was -2.5. And then the y-coordinate turned out to be -12.25. Yeah. Okay, it's a nifty little formula. It is surprising that it is so simple. Okay, taking a look at that parabola up there, our parabola opened upwards, yes? Which meant that that vertex, was it a minimum point or a maximum point? It was a minimum point, right? It was the lowest point anywhere on that graph. You can go forever left and right. That vertex was the lowest point everywhere forever on that graph. And oftentimes it is useful to find the highest or lowest point in like a real world context. So for example, a company might try to maximize profits, find the highest point. If that was a profit curve, find the highest point. Or if that was a cost curve, find the lowest point to try to minimize costs. And so on the activity and on the test and on the final, I'm going to be really cutesy. And I'm going to use words that are synonyms for maximum and minimum, like biggest or smallest or highest or lowest or any synonym for either of those words. And all of those synonyms, you are going to translate into a single word that starts with the letter V. What is it? Vertex. If you see any of those words or any synonym for one of those words, you're saying, oh, Ian is just trying to be funny. He just wants me to find the vertex. I'm not going to be explicit. I'm not going to say find the vertex. I'm going to say find the highest, or find the lowest, or find the peak, find the minimum, right? I'm going to use one of those synonyms, and you just have to translate that into, oh, it's just the vertex, right? So there is this parabola stuff, which we're going to do together in just a minute. But for right now, I want us to jump to the activities, and I just want us to, on page 218, I just want us to find these synonyms real quick. We're just looking for any of those words, high, low, min, max, anything like that. All of them mean find the vertex. In part A, where's the word? What is the word? Maximum. Circle it, highlight it. That says to you, vertex. In part B, maximum vertex, right? Nowhere in A or B does it say vertex. But both of those questions really just ask you to find the vertex. Okay, moving on to next page, number 3. Take a look at 3A. Find the word in 3A. What is it? Maximum. Find the word in 3B. What is it? Maximum. This is slightly different, but in part C, see that hit the ground? It's not max or min when it's hitting the ground. This is one that you did in the activity you just finished. How much is the height if you are hitting the ground? If you are on the ground, your height above the ground is 0, okay? This is just another common translation. You see hit the ground, that means the height is 0. Doesn't mean vertex. The height is 0. Okay, we got. Let's move on to the next page, number 4. Lots of words up there, but I can guarantee you're going to find something that really just means find the vertex. Oh, it's actually not in the words in number 4. It's in part A. Find it in part A. Largest. That's the word. It's the only word I care about. The word means find the vertex. See it? Largest in part A. Okay, moving on to part B. What word do you see again? Largest. That's the vertex. Move on to number 6. Just read A. Number 6, read part A. Underline the word that says vertex. Which one is it? Lowest. That's a new one. But just means find the vertex. And then part B. Where's the word that says find the vertex? Minimum. Starting to get the pattern here? Lots of synonyms. In none of those questions does the word vertex appear, but in all of those questions, you just have to find the vertex. Okay? All right, let's go back to the parabola stuff that we skipped. So we are going to go right here, 216, 216. Okay, so there's a lot of stuff written up there. I'm going to just remind us of what we did with graphing parabolas a few classes ago, and then I will show you the new and improved technique, which will sometimes save us some work. All right, step 1 from our graphing parabolas class a few classes ago was to decide if the parabola opens up or down. Just depends on whether A is positive or negative. Easy. Step 2 is to find the y-intercept. To find the y-intercept, you let what equal what? X equals 0. Easy. Step 3 was to find the x-intercepts. You let what equal what to find x-intercepts? You let the y equal 0. That's hard because you are solving an equation like that. And that either means quadratic formula or the box. Big process either way. Suppose, for example, that we found the vertex very early on in our process because we now have a fancy new formula. Used to be, we could only find the vertex after we found the x-intercepts, and then we'd average them. But we don't need to do that anymore. Suppose that I tell you that the vertex, don't put this, but suppose I tell you the vertex is right there, and that this particular parabola happens to open downwards. How many intercepts is this parabola going to have? How many x-intercepts? It will have 2, yes? Suppose that it's the same vertex, but the parabola happens to open upward. How many x-intercepts will it have? It will have none. And in a case like that, there is no point spending even a moment's time trying to find the x-intercepts because they do not exist. And so what you are going to do is you're going to find the vertex pretty early using the negative b over 2a formula. And you're going to find whether it opens up or down pretty early. That's easy. And if we get lucky, if it happens that the vertex is up above the x-axis and the parabola opens up, you say, I don't need to spend any time trying to find x-intercepts. If it opened down, then you still need to find the x-intercepts. There's no getting around that. Let's look at another case. Suppose the vertex was down here. Only 2 possibilities for the vertex. It's above the x-axis or it's below. Suppose that the parabola opens up. How many x-intercepts would it have? 2, and it's your job to find them. Suppose it opens down. How many x-intercepts does it have? None. And you don't have to spend a moment trying to find them because they don't exist. Okay? And so our new and improved order for our parabola drawing process is right here. Step 1, figure out up or down. That's the same. Step 2, find the y-intercept. That's the same. They're both easy. Step 3 is new. Let's find the axis of symmetry and the x-coordinate of the vertex by using the new vertex formula, negative b over 2a. That's the x. Axis of symmetry is, I don't know that we've used that phrase, but it's just the vertical line. I'll draw it here. If that's my parabola, then the axis of symmetry is just that vertical line that goes right through the vertex because the parabola is just a mirror image on either side of that line. So it's called the axis of symmetry. When I used to be in a gang, my tag was axis of symmetry. So you could see it like graffiti on the wall. Axis of symmetry was me. So we find the vertex very early on right here. And we find both coordinates. And then, this is also new for us, we have to decide if we have no x-intercepts, 1 x-intercept, or 2. You don't need to memorize the stuff in bold, but it basically says, hey, if the vertex is way up high and it opens up, there's none. And if the vertex is way down low and it opens down, there's none. Don't spend any time figuring out what the x-intercepts are when there aren't any, okay? And if there are x-intercepts, you still have to find them. Still need to do a box or a quadratic formula. Okay, so that is the new and improved process. I had intended to do 7 or at least part of 7 now. Why don't we just start the activity? So go ahead and flip over to the next page. You'll have plenty of practice doing parabolas and I will walk around. So move on to the next page, which is the answer key actually. Move on to the page after that, to 18, I think. Yep, to 18. So I think the questions in the activity are going to kind of go back and forth. A word problem, which basically says find the vertex, and then a big graph of parabola problem. I'll walk around.